Alright, so the lesson that we're dealing with today is going to be talking about central angles and arc measures. So yesterday we talked about what an arc was, and we know it is the curved part of a circle, and it's that distance from one point to another. So just some background information before we dive into this, just review of yesterday. A central angle is an angle with its vertex at the center, and its two sides are radii. And what that means is radii is just plural of radius, so both of the segments are part of the radius. And the sum of all central angles in a circle is 360 degrees. And an example of how we would name it is it's obviously we're talking about an angle, so it's angle. And then the vertex needs to be the middle letter, so angle ABC would be a central angle. Alright, the degree of the arc. So now we're talking about that curved piece formed by the endpoints of a central angle is equal to the degree of the central angle. So if I see that ABC, angle ABC is 84 degrees, what that's saying is the arc that is formed by that central angle is equal. So if the angle is ABC, then the arc AC is going to be equal to it. So it's going to be 84 degrees. Alright? So now I see that this is an arc marked by 3 letters, so that means that it's a major arc. So it's going to be ADC. So I'm talking about the rest of the circle. So I'm going to think about if the whole circle, so all the way around, from point A all the way around, is 360 degrees, and I know that the purple part, or that minor arc, is 84 degrees, then I can find the measure of the major arc by taking 360 degrees, so the whole circle, and subtracting out the part that is the minor arc. So 360 minus 84 is 276 degrees. So the major arc is 276 degrees, the minor arc is 84 degrees. Some other things to remember as we work through this section is vertical angles. And we know vertical angles are equal. Also, the measure of a semicircle is 180 degrees. So as we work through those, we want to keep those ideas in mind. So as I'm looking at these problems, I always want to start with, what do I see? Okay, so I see that I have a circle. I see that JL is a diameter, and I see that KM is a diameter. I also see that JNK is a central angle, and it's 21 degrees. Alright, so once I've looked for everything I see, what can I infer? Alright, well, I notice that JNK is a vertical angle to LNM. So, vertical angles are congruent. So, if this is 21 degrees, then that makes this 21 degrees as well. Okay? So, those are pretty much all that I can infer right now. So, I'm going to move on and start answering these questions. Alright, so it's looking for the measure of arc JK. Okay, well, arc JK is this arc right here, and I know using this idea up here that the degree of the arc is equal to the central angle that is formed by those two segments. So JNK is 21 degrees. That means arc JK is also 21 degrees. So when I look at number 2, or part, the second one, it's asking for the measure of angle JNM. So JNM is this angle right here. Alright, well, earlier I had noticed that MK is a diameter. So that means that it is half of the circle. So if the circle is 360 degrees, then the distance from K to M is going to be 180 degrees, okay? Well, the angle JNM is a little bit less than that 180 degrees. So if I took 180 and I subtracted off this 21, it's going to tell me JNM. So to find that, I'm going to take 180 minus that 21, and I get 159 degrees. All right, so my next one, the measure of arc KL. All right, well, KL is this arc right here, and I don't have an angle measure for KNL, but I notice that JL is going to be a diameter. So the measure from J to K to L is 180 degrees. And I know that from J to K is 21. So if I take 180 and subtract off that 21, it'll tell me what that arc is. Okay, another way I could have thought about it is I could have noticed that JNM, which I know is 154 degrees, this angle, I could have seen that JNM and KNL are vertical angles. And so if this angle is 154 degrees, that means this angle has to be 154 degrees, which makes this arc, because that's a central angle, also 154 degrees. So that's two ways I could have thought about it. All right, let's look at the next one. So measure of arc JKM. So JKM is this big arc right here. Okay, and the K, because of that K, it tells me that I'm not going J to M, I'm going J to K to M. So it's a major arc. Okay, so I know that the measure of a whole circle is 180 or 360 degrees. And I notice that this major arc goes everything except for JM, the minor arc JM. So really I could think about it as 360 degrees minus this minor arc J to M, well, which is 159 degrees. So when I do 360 minus 159, I get 201 degrees. So let's look at our final problem on this one. The measure of arc MKL. All right, so MKL is almost the entire circle. So I'm talking about that major arc right there. So as I go from M to K to L, it is the whole 360 except for this little piece right here, the minor arc ML. So I'm going to think of it as 360 degrees minus my minor arc, which ML, arc ML, is going to be equal to the central angle, which is 21 degrees. So I'm going to subtract off that 21 degrees, and I get 339 degrees. So go ahead and try 3 and 4 on your own and see how you do. Don't forget to use what do I see, what can I infer, and then draw those conclusions. Alright, so for number 3, you should have gotten that arc CD is 90 degrees. You should have gotten that arc FD is 124 degrees. You should have gotten that arc DCF, so major arc, is 236 degrees. And you should have found that arc GDF is 304 degrees. So if you got those answers, you can move on to the next one. If you didn't, I'll explain them now. Alright, so arc CD is going to be made up of angle CHD. So when I see this is a 90-degree angle, then that arc is also going to be 90 degrees. Alright, when I look for a measure of arc FD, I see that it's this piece right here. Well, I noticed that CE is a diameter, so if this is 90 degrees, then this is also 90 degrees. And I'm going to go ahead and also say that this is 90 degrees because that will help me later. So if this is 90 degrees, that makes this arc 90 degrees, and this arc is 34, so 90 plus 34 is 124. All right, so for major arc DCF, so I'm talking about the purple right here. All right, I know that this is a semicircle or a diameter, so that means it's going to be 180 degrees, which I noticed also because 90 plus 90. And then I also noticed that CE was a diameter. So this whole angle right here, GHE, is 90 degrees. So I took that 90 degrees and I subtracted off 34, and that told me this arc right here from G to F was 56. So I did 90 plus 90 plus 56, and I got 236 degrees. All right, and lastly, GDF, arc GDF is this major arc right here. So I did 360 because it's almost the whole circle, except for this piece right here, which was 56. So 360 minus 56 is 304. All right, so for number 4, for the first one, arc PQ is 71 degrees. Arc SR is 161 degrees. Major arc QRT is 199 degrees. Arc SPSR is 270 degrees, and arc PS is 109. All right, so yesterday we talked about this idea of an arc length. So we looked at what if I took a fourth of it, what if I took half of it, things like that. So we talked about an arc length is going to be a percentage of the circumference, right? So the circumference is if I go all the way around, and so an arc length is going to be a part or a percentage of the circumference. So percentage is going to be the angle over 360 because the whole distance around is 360 degrees. So if I take whatever angle I have and put it over 360, that'll give me my percentage. In math, of always means multiply. And then circumference, we find the circumference of a circle by 2 pi r. So we're going to be using this idea to find the lengths of these arcs. All right, so we're going to start with our questions. What do I see? What do I know? And what can I conclude? So when I look at this, I see that EB is 15. So when I look at EB, I see that that's the center to the edge, so that's the radius. I also see that I have angle BEC, which is 68 degrees. I also see that I have 2 diameters drawn in. So then what can I infer, or what do I know? Well, I know that angle BEC is 68, and that would make that arc also 68 degrees, but I'm looking for the length. I know that BEC and CED make a diameter, so I know that they are supplementary angles. I also know that BEC and AED are going to be vertical angles, so they're across from each other. All right, so what can I conclude? I'm looking for the length of CD. So I'm looking for this right here, and I want to know the length, not just the angle measure. So to find the length, I know I'm going to use my formula up here. It's going to be a percentage of the circumference. So the circumference is going to be the distance all the way around. And I just need to find what percent of that total distance is right here. So I need to know what angle. Well, like I said before, I know that BEC and CED make a diameter, and I know the measure of the diameter is 180. I can also think of arc BCD makes 180 degrees, and it's made up of BC and CD. So either way you think about it, to find this angle right here, I'm going to do 180 minus that 68 that I already know. And that leaves me with 112 degrees. So I know that arc CD is 112 degrees, but it's not asking me for the degrees, it's asking me for the length. So I need to find the whole circumference and then find out what 112 degrees, what percent is 112 degrees of that whole part. So I'm going to say 112 out of the 360. So the percentage of their circumference, and the circumference is 2 pi times r, and I had found that r is 15. So I'm going to say in my calculator 112 divided by 360, and that's going to tell me my percentage. So it's roughly 31% because it's 0.311111 repeating. So CD makes up about 31% of the 360 degrees that represents the whole thing. And then this is going to be 2 times 15 is 30, so 30 pi. So I'm just going to type that all in. And I'm going to use the pi button. It's above the, to the power of, above the divide sign. And I get 29.32. And it's centimeters because it is a length. So I know that arc CD is 29.32 because it's about 31% of the whole circumference of the problem, or of the circle. All right, so go ahead and pause the video, and I'd like you to try number 11. Set up number 11 as much as you can. So hopefully for number 11, you were able to get 27.65 feet. If you did not get 27.65 feet, I'd like you to look at my work and mark down any questions that you have about any of my work or where I got any of the numbers. And we will talk about the remaining examples tomorrow in class.